In our previous video, we looked at Euler's formula, e to the I theta is cosine theta plus I sine theta. And in the video before that, we were talking about the connection between complex numbers and polar coordinates. So we have a connection between complex numbers and polar coordinates. We have a connection between complex numbers and the exponential function. And this video is going to explore that these two things here are basically closely, intimately connected themselves. And here's the punchline. A complex number z with polar coordinates r theta can be expressed in this form as r times e to the I theta. Why is this? And r, of course, is always the modulus of z. Why is this? Well, let's write out r. So r times, what is e to the I theta? It's cosine theta plus I sine theta. And so then if we distribute out this multiplication, z is equal to r cosine theta plus I times r sine theta. And this right here is x. And this right here is y. We're writing our complex number z as x plus iy using polar representations of x and y. So all of these formulas, this one, this one, this one, they're all intimately connected here. So we have ways to write complex numbers in polar form. We have ways to write complex numbers in exponential form. So all of this stuff is very related. One thing that this can do here is we can find exponential forms of numbers. So for example, let's use the number that we used in a couple of videos ago. Z is equal to -2 square root 2 plus 2 square root 2i. And if you recall, a couple of videos ago, r was equal to 4 and theta was equal to 3 pi over 4. And so we are able to write this. We are able to write this as z is equal to r e to the I theta. We can write this as z is equal to 4 r e to the I times 3 pi over 4. So here is an exponential form of the number z is equal to -2 root 2 plus 2 root 2i. Another number here, I think a couple of videos ago, we looked at z was equal to -2i, where r was equal to 2 and theta was equal to 3 pi over 2, or you could use -pi over 2, both would work. And so once again, all we have to do is write down z is equal to 2 e to the I times 3 pi over 2. And we are done with that. And so the thing here is that this form right here, this exponential form of a complex number, is going to prove to be very, very important for us a couple of videos from now. Let's do one last example. Let's go from exponential form to rectangular form. If I were to give you z is equal to 5 e to the I pi over 3, we could write this as z is equal to 5 times cosine of pi over 3 plus I sine of pi over 3. And so cosine of pi over 3 will be 1/2. So 5 times 1/2 plus I times 5 sine of pi over 3 will be √3 over 2. So 5/2 plus I times 5√3/2. So the one thing you should be able to do at this point is make sure that you're comfortable converting between polar form, rectangular form, and exponential form. You should be able to go from any one of those three forms to any other one.